Now, in this video, we're going to be looking at modeling a Fourier series by the definition using an even function. So the function we're going to be looking at here is x squared. I'm going to go from -2 to 2. So again, it's first worth pointing out that that means that L is equal to 2 in this example. And so we're going to need to be calculating these three integrals in order to fill out our Fourier series. So we're going to start with a sub 0, and we're going to fill in our values for L. So 2 times 2, and we're going to go from -2 to 2, and our function is x squared. Now, this is an even function, x squared is, and so we can use properties of even functions. This original fraction here is 1/4, and then we're going to integrate twice the integral from 0 to 2 x squared dx. And so we'll end up with the antiderivative of x squared is x cubed over 3 better, from 0 to 2. And so that's going to give us 1/6. And if I plug in 2, I'm going to get 8. And 0 will give me 0. And so I end up with 2 canceling, and I get 4/3. All right, so that's a sub 0. So now let's look at an. Again, we're going to replace our L's with 2 everywhere. And f of x with x squared. Now this is an even function times an even function, which is an even function. And so I'm going to multiply by 2. Again, we had the 1/2 out front. I'm going to pull out a 2, and then I'm going to integrate from 0 to 2 of x squared times cosine of n pi x over 2. Now, this is also going to be integration by parts. So if I apply my first step of integration by parts, I could do this by the tabular method, but it'll only require 2 goes, so I'll just do it out by hand. So u is x squared, and then dv is going to be cosine n pi x over 2 dx. And then du is going to be 2x. And v is going to be the antiderivative of cosine. So that'll be negative cosine, that'll be positive sine n pi x over 2. And then if I'm taking the derivative, I would multiply by n pi over 2. But since I am doing the antiderivative, I divide by that. And so now I'm going to get the 1/2 and the 2 outside my integral cancel. And so I'm just going to end up with x squared times 2 over n pi sine n pi x over 2 uv minus my integral of, I can bring my 2 over n pi out front, going from 0 to 2 of 2x sine n pi x over 2. And again, the 2 I could pull out and I could make that 4. And of course, on this one, we are technically evaluating between 0 and 2. All right, so that's not yet ready to finish integrating, so we got to do another step of integration by parts. So u is x, dv is sine n pi x over 2, and that means du is dx, and v, the antiderivative of sine, is negative cosine n pi x over 2. And then also, if I were doing the chain rule, I would multiply by n pi over 2. And so in the reverse, I divide by the same thing or multiply by the reciprocal. And so now in here, we're going to have our 4 over n pi coefficient we had from before. And we're going to evaluate uv. So that'll be negative 4x over negative, 2x over n pi times cosine n pi x over 2, and then minus zero to 2. And again, we can pull out our minus 2 over n pi. But now it's just inside our integral cosine n pi x over 2. Now, before we continue, I'm going to simplify this a little bit so that I don't have to keep carrying around embedded parentheses. And of course, this piece should actually go out here. With its own negative 4 over n pi. So this negative 4 over n pi, remember, it applied to this entire integral. So it applies to this part that we've evaluated. It also applies to the second part that we haven't finished evaluating. So in this particular case, we're going to end up with So what's going to come out of here? Minus, minus, this is going to become a plus. And this is going to be 4 times 2 is going to be 8x. And then n squared pi squared and cosine. And then this is a minus, 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 so that'll be a minus. And this will be 4 times 2 is 8. And n squared pi squared. You get rid of this guy. And then we still have to do this antiderivative right here. This we do not have to do a integration by parts for anymore, which is good. And so we're just going to do the antiderivative, negative this coefficient. And then when I integrate cosine, I'm going to integrate cosine to get sine n pi x over 2. And then I'm going to multiply by another 2 over n pi. And so if I combine these coefficients a little, then this is going to become 16, and this is going to become a cube, and this is also going to become a cube, and I can get rid of that. Now, I have to plug in x equals 2 and x equals 0. So let's see what happens when I do that. So 2 squared sine of 2n pi, let's put it over here in front. 2n pi divided by 2 is just going to be n pi. And this is going to be times 2. And then this is going to be 2n, this x is 2, divided by 2, this is going to be n pi. And then this is going to be 2, that's going to divide by 2, this is going to be n pi. And then when I plug in the minus version of this, then this will be 0, which means this whole thing is 0. And when I plug in 0 here, then this whole thing is going to be 0. And then when I plug in 0 here, sine of 0 is 0. And so that means this whole thing is going to be 0. So these are all 0. These are all 0. And then if I'm looking at evaluating these ones, now again, integer multiples of pi are going to be 0, right? 0 pi, 1 pi, 2 pi, they're all 0. So this one is also 0. And this one is also 0. And so all that's left is this one that's not 0. And of course, keep in mind that cosine of n pi is equivalent to -1 to the n. And so that's going to be our a sub n coefficients. Now, if we continue with b sub n, so let's scroll back up here and grab my formula. B sub n, fill in our 2's. And this will be x squared And if I fill in my 2 over here. Now, sine is odd, x squared is even. Odd times even gives me an odd, and that means by symmetry, integrating from negative a to a of an odd function gives me 0. So all my bn's are 0. And so let's fill out our final formula for our Fourier series. So this we established was 4/3. And then our a sub n, we decided was this. And then b sub n was all 0, so the rest of this goes. Now, what we would want to then show, if we could, was that this would actually work as a model. So let's write out the first couple of terms and see how we do. So when n is 1, this will be negative 16 over pi squared, since n is 1, cosine of 1/2 pi x. And then plus, now when n is 2, n squared will be 4. So this will be 4 over pi squared. It's positive because we're flipping sign. And then when n is 2, we'll just get cosine of pi x. And then minus 16 over 9 pi squared cosine of 3/2 pi x. And then when n is 4, it'll be 16 over 16, so 1 over pi squared cosine of 2 pi x dot dot dot. Now let's see how we do on the graph. So this is our first 2 terms of our approximation, and you can see that it's already doing a reasonably good job. If we add another term divided by pi squared cosine pi x, and then the next one would be minus 16 over 9 pi squared cosine of 3/2 pi x. And as I keep adding terms, you can see that in this region between -2 and 2, it becomes more and more and more like the function that we are trying to model, except that it also has the periodicity.